So we're looking at page 60, and in this video we're going to work through the process for conducting an experiment or an observational study. And you'll see that the process is very similar for both. It's just a question of what your objective is, number one, but also a couple of little ingredients here and there. So I'll go right to the example. Design an experiment that will test the effectiveness of Vicodin, which is a pain-relieving medication. Your EUs, or experimental units, are the students in our class. Now, I'm doing this as a video, so the experimental units will not be the students in our class, so I'll need a fictitious grouping of students. So to keep it simple, I'm just going to use the letters of the alphabet. Not all of them, but some of them. Otherwise, we'll be here for a little while. So my EUs: A, B, C, D, E, F, G, H, I, and I'm thinking J. Right. Actually, the hesitation was to make sure that I had 10 letters. Right. I don't want to go too crazy. I want to just have 10 experimental units. So the design: identify the problem to be solved or the claim to be tested. All right. You can itemize it step by step if you want. Really, I mean, you can kind of come up with the whole process, and then later on just kind of earmark which is which. Really, the idea here behind everything is that we have a concrete approach, something that a person can kind of just look at without having to have really a deep understanding of the context. They could just look at it and say, oh, I know what you're talking about. All right. So to do that, what I'm actually going to start off with is a diagram. All right. This is a very popular approach. And as far as assessment is concerned, this is something I'm going to require of you. We start with the experimental units. And through a simple random sample, we're going to break them up into two groups. All right. The two groups would be the control group, and the other group would be the experimental group. My pen's on the fritz. All right. Now, the way I'm going to handle this is the control group is going to get a placebo, which does not start with the letter B. And the experimental group is going to get the Vicodin. Now, as I'm doing this, you may question, why do we need to do this diagram, especially if we're going to have to detail everything? Well, that's the idea. If you do a nice enough diagram, a complete enough diagram, it should answer a lot of the questions that are in that list, the process list. And so really, we just have to kind of detail out anything that has not been addressed by the diagram. All right. So the placebo is going to either be effective or not. All right. So measure pain relief. And that's going to happen whether it's the placebo or the Vicodin. And then we're just going to compare the two. All right. Now, there are some things that have gone unaddressed, like how do we measure pain relief? In a follow-up to that would be how do we compare two things that we don't know the value of? But let's just cross one bridge at a time. All right. I am going to make this a double-blind experiment. And when I detail out all the missing ingredients, that'll become clearer as to why I chose to do that. All right, so a little frog in my throat. So a problem to be solved or claim to be tested. All right, so might as well address that right now. Is Vicodin effective for relieving pain? All right, I don't want to get too cute with this because the question was really to determine the effectiveness of Vicodin, which is a pain relieving medication. So, if you get too cute, you might say something like, "Is Vicodin a viable treatment for chronic pain for individuals, in the age group of this, that, or the other thing?" That's too specific. All right, we keep it general. All right, or at least as general as the question is. Explanatory and response variables, that's kind of already been addressed, but let's be a little bit more explicit. So the explanatory variable explanatory and response variables are our input and output variables. So I'm going to input something and hope to get a result as an output. So amount of Vicodin in the case of a placebo, there's no Vicodin. In the case of the experimental group, there's some Vicodin. I'm not a doctor. I'm not a medical researcher, so I don't know dosages related to Vicodin. And even if I did, I don't know what the subject of this study is. So I'm just going to say amount of Vicodin. Response variable now, I categorized it as pain relief. So this would be the amount of pain relief. Okay. If you had decided to measure just the level of pain, then it would be the amount of pain. All right. So there's a couple different directions you can go there. Determine the level of factors that affect the response variable. All right, so the factors. Oh, geez. There's like infinitely many. That's not true. There's just a lot. We could be talking about physiology. I mean, if you decide on a set dosage and a person's height, weight, age, things like that might come into play. The type of ailment causing the pain. The diet. Because, if you're talking about pain that's caused by inflammation, if they have, and I'm learning about this as I go, but if they have a diet that's rich in anti-inflammatories, like, what is it called? Turmeric. I don't know if I pronounced that right. I'll take that as an Easter egg. Just a simple yes or no on whether I pronounced turmeric correctly. All right. So, yeah, those things might come into play. All right. And so we list a few of them, but the idea behind listing any of the factors would be to get at anything that might become a lurking variable, because these are the things that we want to control. All right. In a proper study, we want to control all of these factors lest they become lurking variables. Otherwise, they become lurking variables. All right. And a lurking variable is so detrimental to a proper experiment that it pretty much ruins it. Right? So if you have a lurking variable, it's something that, you know, it's a reset. You're looking at something that's like, well, I don't have any meaningful conclusion that can be drawn from this study, so I have to start over. I'll give you a quick example. I broke out into hives over the weekend. So obviously an allergic reaction to something. So is it the detergent used for the clothing? Is it the fact that I ate tomatoes? I like tomatoes. People have been known to be allergic to tomatoes. Is it some kind of medication that I'm on? Right? Now, there are certain things that I can remove and try to flesh out what the causal factor is. But as, you know, just a human being, you think of the worst case scenario. Right? So the first time you break out in the hives, you're like, oh my God, I must be allergic to, and then you think of the thing that you love the most. Right? Well, I mean, I don't think I could live without tomatoes, so I'm allergic to tomatoes. So there goes that idea. I guess I won't be enjoying food for the rest of my life. But then I haven't eaten tomatoes for a few days, and I still break out into hives. Right? And, you know, this morning I woke up, got out of bed, and the part of my body that had hives on it was the part of my body that was in direct contact with the mattress overnight. So then that becomes all right, so what are some characteristics about a mattress that would lead to a person having an allergic reaction? So now, is it dust mites? Is it material that makes up the mattress? Is it the detergent? All right, so now I can control the detergent, change the detergent. If it happens again, now I'm looking at dust mites. Okay, is it dust mites? All right, I don't know how I'd be able to figure that out. Maybe get a hypoallergenic mattress cover. Right, and in that case, at least I've narrowed it down to, okay, it was something about the mattress that was causing the problem. All right, but if I don't do anything to restrict the variables that are in play, then I'll never be able to draw a meaningful conclusion. All right, so these factors are so important that if you don't control them, it ruins your study. All right. Sample size. We have 10 people, so now I got to start breaking them down. So that's where our calculator comes into play. So I'm going to go with, I don't know why I turned that off. I'm going to go with red for those keeping score at home. Control. And then green for experimental. So what I'm going to do in my calculator, I'll just kind of tuck it in over here, because this is something you would do on the side. I would use random integer. Zero and one. I'm going to use 0 and 1. There's other ways you could design it, but this is what I choose to use. Choose to use. And I'm just going to go down the list. If I get a 0, that individual goes in the control group. If I get a 1, that individual goes in the experimental group. So math, probability option 5, 0, 1. Try to keep it simple. All right, person A, because again, I have my list of experimental units. A got a 1. All right, 1 is experimental. So A is in the experimental group. On your calculators, if you just hit enter again, it'll redo the random integer. I have to do the additional step. B is also going in the experimental group. C is also going in the experimental group. Let me see if I could do it as a second answer. Not second answer, second entry. D is going in the control group. I was starting to get worried that there was something wrong with my random integer function. It's random, so it's possible I can get 3 in a row that go in the same category. E is going in the experimental group. So is F. Now this is possible. G. I got to get to I. H. Oops. Second enter. Yeah. Okay. So everybody but D is going in the experimental group. All right. On your calculator, you'll get a different set of outcomes. For me personally, I would be looking to probably toss this set of outcomes and maybe make a new set of outcomes. Another way to handle it would be, so another possibility, or if you don't like the set of outcomes that you're getting, you could change the approach that you take. I could do random integer, lowercase. All right, so I could just do that process again, 0 to 1, and just keep hitting enter and see what comes up. Or I could do 1 to 10, even goes into control, odd goes into experimental. All right, so I didn't like this outcome. I'm going to compare 9 people against 1. That doesn't seem to work. So let's try it this way. Nothing wrong with the other way. I just didn't like the outcomes. 1, 10. 3. Okay, so if it's odd, it's going to go into the experimental group. Sorry, brain cramp there. And we could do that 10 times. Or, yeah, we'll just do it this way. So experimental group. Control group. So A, B. C. D. It gives us a few more values that could pop up. I mean, you could go from 1 to 5, you can go 1 to 30, you can go 1 to 100. It's just you're looking for that 50-50 split between even and odd. All right. Odd is experimental, so we're up to E. This whole alphabet thing seems to be throwing me for a loop. 8 came up, I think, again, so it's back to control. F seems to be going back and forth, which is kind of nice until that happened. G. H, and one more, I. All right, so I think I'm missing one. A, B, C, D, E, F, G, oh, J, sorry. It didn't stop at I. And then back to 1, so J goes in the experimental group. All right, so actually we have a 50-50 split, so this is a much nicer outcome. All right, you can go either way. It's up to you. This one obviously works a little bit better, or at least based off of the random integer in my calculator. You might have gotten a nice array of outcomes using 0 and 1, when you do it on your calculator. So, whichever method you like better. If you go like I said, 1 to 100, it's just more numbers for the calculator to choose from, less chance for it to repeat values over and over again. All right. So level of a response variable. Well, it's nominal, ordinal, interval, or ratio. Well, if we just were to say, so just thinking in terms of nominal, the nominal level of data, that's just something it's just got a name, but that name doesn't have a numerical value. Well, I don't know that would make sense here, because if I tell you to classify your pain and you say bad and somebody else says good, there is a difference between those two things. Not just that they have different names. One is more intense level of pain than another. All right. The amount of pain relief. Well, depending on how we measure this, we could be looking at a lot of different possibilities. But if we're going with the scale of 0 to 10, then it's more finite. What I would say is 0 is none, no pain relief, through 10, complete pain relief. All right, so no pain relief through full pain relief. You could go the other way around, because 10 is often worse than, or considered to be worse than 0, 0 being the best. But again, since we're looking at relief as opposed to measuring pain, or at least that's what I chose to do, this seems to make sense to me. But again, you have a lot of freedom to design it any way you want. All right. If you have any questions about a thought process, it's like, I was thinking of measuring it this way, just send me a message and we'll talk about it. All right. So if that's the case, if we're going with this particular scale, then looking at nominal, ordinal, interval, or ratio, it's not nominal. Ordinal would just be that there's, a ranking system, but there's no meaningful difference between the different levels. Well, what I have in mind here is that 10 is twice as, I'll say, intense, just to keep things as simple as possible. 10 is twice as intense as 5. That's a graduated sort of measuring system. And so ordinal wouldn't make sense because the differences between values would have meaning, putting us in the interval level. But then since 0 can be part of the set, based off the measuring system I came up with here, it would be the ratio level. All right. Now, again, this is going to vary depending on what you define as your system for measuring the amount of pain relief. All right. If your system is thumbs up, thumbs down, it's still not nominal because thumbs up would be good, thumbs down would be bad. But what's the difference between thumbs up and thumbs down? I don't know. So that would put you in the ordinal level. All right. Collect sample using randomization and replication. Randomization we just did in order to come up with our sample to begin with. We had our sample size given to us, so we didn't really have to determine that. We kind of killed two birds with one stone. Replication is a little bit of a different story. Replication means that when you conduct a study, when you conduct an experiment, you don't collect one sample and call it a day. Right? In fact, here, you could look at this as me collecting two separate samples. Maybe I ran the entire experiment on that first sample where the control was just individual D and the experimental was A, B, C, E, F, G, H, and I. And I drew some kind of conclusion from that. But then I was like, you know what? That's pretty rare that only one person would end up in the control group and everybody else in the experimental. So let me do it again. So then I collected another sample. Let me do it again. Let me do it again. Let me do it again. And after 6 months, after a year, I have hundreds upon hundreds of samples. Then, using that information, I can start talking about what's really going on. All right. So that's the replication part of it. In a classroom, not going to happen. Right. It's just not practical. But we can still consider the meaning and the importance of replicating a study. Apply the selected treatment? Well, no. I'm not allowed to give out Vicodin to students. I don't have any anyway. So yeah, that's not going to happen. But we can say on paper we're applying the select treatment, and that happened in the diagram. So we've got that accounted for. Test the claim. The claim is testing the effectiveness of Vicodin. That's all part of the diagram also. All right. So the diagram kind of addressed in kind of a nutshell everything that was going on. We just kind of fleshed out a little bit more below. And I wrote a little bit more than I needed to, but it makes sense, at least for the first time through. All right. So what I'm going to do is I'm going to send out a PDF file that contains a set of hypothetical examples. I'd like you to work through those over the next couple of days. And on Thursday, I'm going to send out an answer key. And if you have any questions on that, you can message me. Actually, I'll send out the answer key right away. I won't wait till Thursday, but message me, ask me questions, and I'll briefly go over it before we actually start on hypothesis testing, which is actually how we use information drawn from an experiment to actually generalize about a population at large.